2.3 times 10 to the third newtons. Notice I put it in scientific notation to make sure that I indicate that there's only two significant figures. Okay, that's what the problem said. Could we at this point calculate what the acceleration is? We could, because the acceleration is simply the friction force divided by the mass. So we could say that it's the friction force divided by the mass, which would be 2.3 times 10 to the third newtons divided by 745 kilograms equals an acceleration. I won't calculate it. It wasn't part of the problem. But notice one thing very interesting. The friction force acts back. The block is sliding this way. The friction force acts back. So what does that mean? The acceleration acts backwards. If the velocity is going this way, if the friction force is negative force, which we would say, because we would say that forces in this direction are plus, forces in this direction are minus. So this gives really a minus acceleration, which means what? It's accelerating in the opposite direction. Now, can you have that? Absolutely. What does that mean? The box is slowing up. So what that means is that, let's actually, just for the fun of it, calculate the size of this. And I get minus 3.1 meters per second squared. So what that means is, just as an example, it has a certain velocity this way. And let's say we have the initial velocity, but there's a minus acceleration times delta t. So what that means is that the velocity, right now the velocity is a certain velocity, but it's slowing up. There's a de-acceleration going on. The friction is applying the brakes, and so over time the object will eventually come to a stop because the velocity is going down. Okay? Okay, question number 8. Okay. While driving down a country road, a man has to stop because of a 314-pound rock has fallen on the hill and has landed in the middle of the road. And it gives a coefficient. Here's the rock. And we know what the weight is. The weight is given as 314 pounds. Pounds is a weight. Okay, X down. And we have that the static coefficient of friction is 0.45. We have that the kinetic coefficient of friction is 0.32. The question is, what is the magnitude of the frictional force that the man must overcome to move the rock? So he wants to move the rock, he wants to apply a force. Question is, how large a force does he need to apply? Okay. Well, remember, the weight acts down, the normal force acts up. The sum of the forces in the y direction is we have the weight acting down and the normal force acts up. The sum of these equals 0. The mass is not moving vertically. So the normal force is equal to the weight, which is the mass times acceleration, mass times degree. But we already have what this weight is. The weight is actually 314 pounds. So the normal force is 314 pounds acting up. Okay? In this case, the rock is not moving. we're not going to use a kinetic, we're going to have to use the static coefficient of friction. He's going to push it this way. We want to just barely get this velocity just a little bit greater than 0, so the friction force will act back. So the sum of forces in the x direction is we have a force applied to the right, and we have to subtract the friction force, which acts opposite that. And we want this equal to a mass times acceleration. Right now, there is no acceleration. In fact, there's no velocity. And so we just barely want this to be equal to 0 or maybe slightly greater than 0. Okay, so the minimum force he has to apply is the friction force, which is the coefficient, static coefficient, times the normal force. So the force he has to overcome is 0.45, the static coefficient, times the normal force, which is 314 pounds, which is 0.45 times 314, 141 pounds of force. So that will be the minimum force he has to apply to just barely get the rock moving. To really move it quicker, he has to push with more force than that. Okay, so that's question 8. Okay, question 9. A construction worker is sliding a 74-pound box of bricks across a wooden floor. The mass is 74 kilograms, and he's pushing it this way. He's sliding a 74-pound box of bricks across a wooden floor. It gives you what the coefficient of static coefficient of friction is, 0.26, as well as a kinetic coefficient of friction, 0.12. And he pushes with the force of 92 newtons. The question is, how fast will the box accelerate? So calculate the acceleration of the box. Okay, well, number 1, the first step is to look at the sum of forces in the y direction. We have the weight acting down, the normal force acting up. The weight is opposite the normal force, which means that the normal force is equal to the weight, which is the mass times gravity, which is 74 kilograms times 9.8 meters per second squared. So the normal force is 74 times 9.8, which gives 725 newtons. I'm going to just leave it like that just for the time being, 725 newtons. The second step is to look at the sum of the forces in the x direction. We have a force being pushed to the left. I'm going to just draw a left arrow this way. Friction will this time act this way, opposite. So friction is opposite that, which in this case is to the right. I'll just use the arrow to indicate the actual direction of the forces. And that's equal to the mass times the acceleration. The force that is applied, 92, here's your 92 pounds, minus, let's see. It says that the box is sliding. If the box is already sliding, that means we're going to use the kinetic coefficient of friction. Box is already sliding, so we use the kinetic coefficient of friction. The kinetic coefficient times the normal force equals to the mass times the acceleration. So I'm going to erase this just for the room. Let's solve for the acceleration here. Take the force and we subtract the kinetic coefficient times the normal force, and we divide that by the mass. Excuse me. That's the mass. That equals the acceleration. We take this and we divide that by mass to get the acceleration. So at this point, we can plug into our equation here. The force is 92 newtons minus coefficient of friction, 0.12, times the normal force, 725 newtons, divided by the mass, which is 74 kilograms. That's equal to the acceleration. Now let's calculate this first. 0.12 times 725 is equal to, this is equal to 87 right in here. Okay, so 92 minus 87 is 5 divided by 74. Whoops, 92 minus 87 divided by 74, I get 0.068. I'm going to round it off to two significant figures. 0.068 meters per second squared. That is the acceleration. So that's how you solve that problem. Now, on to number 10, which is the last problem. Okay, number 10. Okay. A young boy found a large box that can be used to build a fort. He put some other treasures in it, into the box, so that the weight of the box is 11 pounds. So you have a box here that the weight is 11 pounds. Okay. He tried to pull, he tied it to the back of his bike and is pulling it down the road. So here's the bike. And here's the boy sitting here, pedaling the bike. How's that? And he has a rope tied here from here to the box. And he's pulling the bike. And they list what the coefficient of, the static coefficient is 0.45. The kinetic coefficient is 0.32. Okay, the question is, what force must he pull the box in order to keep this moving at a constant velocity? Okay, you understand? So in other words, there is a friction force here. Since he's moving, is it static or kinetic? It's kinetic, so we can ignore the static friction. So the friction force, there's a friction force here. And the question is, what force must he pull this in order to keep his velocity going at a constant speed? Okay. Now, think of it. If he wants to pull at a constant velocity, his force must counter the friction force so that the sum of forces is 0. If the sum of forces is 0, that means he'll be able to maintain a constant velocity. That makes sense? Okay. The first step is the sum of forces in the y dimension. We have the weight acting down and the normal force acting up. The weight and the normal force counter each other, equals 0. That means that the normal force is equal to the weight, which is 11 pounds. So that is the normal force, 11 pounds. Okay, here, the sum of the forces in the x direction, he's going to push forward. He's going to apply this force. The force he pushes forward with is the force that the rope pulls with. So that force acts to the right. Acting opposite that is the friction force, which acts in the opposite direction, and that's equal to the mass times the acceleration. Sum of forces equal mass times acceleration. Now, he wants the velocity to be constant. Remember, the acceleration is a change of velocity over the change of time. To have a constant velocity means that the change in velocity is 0. That means that the acceleration is 0. So this whole term is equal to 0. So the force he needs to pull with is equal to the friction force. Okay? That's the force that he must pull with. So the friction force is the kinetic coefficient of friction times the normal force, which will be 0.32 times 11 pounds. So 0.32 times 11, and we get 3.5 newtons. So in order to maintain his constant velocity, he must keep a constant force on the box of 3.5 newtons to the right.